Today we're going to use the Teensy 4.1 and an LED matrix to create a scrolling Halloween marquee. The marquee can say anything you want it to say, but today we're going to make it say Happy Halloween. Let's see what all you need to complete this project. For this project we're going to use the Teensy 4.1 with a 32 gigabyte SD card and a USB type A cable to plug it into the computer, and then we're going to keep that on a breadboard. This is an 8x32 LED matrix. We have two of those. This matrix is the WS2812B RGB LED matrix. They are individually addressable, and I'm using two of the 8x32 panels. These LEDs are the 24-bit full color LEDs, and they're 5 volt. So if you look down in the precaution section, it says that you could use over 15 amps of current if you turn all the LEDs to white, which they do not recommend because they don't think the PCB can handle that. But we won't go anywhere near that current requirement if we're just doing a scrolling marquee like we're going to do here today. And we'll be using this 24 volt 20 amp power supply. This is great for LEDs. I'm going to use that today. This is the iMake or iMac or whatever, however you pronounce that, adjustable power supply with LED display. I've used this for a long time and it's an excellent choice for a lot of LEDs in your project. When you put these two panels together, you're going to have a marquee that is an 8x64 matrix. And you want to know which side is your data in and your data out. If we flip it over, we can see which side is data in. You can see right under the wires here, DN, that's your data in, that's your data out. Your data in is going to connect directly to your microcontroller. Your data out will connect to the second matrix, data in. So you want to be sure to keep that in the correct orientation. Speaking of orientation, some people like to have the wires on the bottom. I like to have them on the top because it gives me a little more freedom and they're not in the way. But remember, if you change your orientation, you'll have to adjust your code. Now it's time to connect the data outside of the right matrix to the data inside of the left matrix. And this way we have one long continuous marquee. Now I'm going to connect the negative wire of the power source to an unused row on my breadboard. I'm going to plug in another wire into that same row and connect it to my microcontroller. If we zoom in, you can see the ground pin there on the left and pin 6 here on the right. Now I'm going to connect that pin to the ground pin here on the microcontroller. Now I'm going to flip this over and identify the ground pin on the back of the matrix here, and I'm going to connect that to the ground pin on the microcontroller and plug it into the same row that we've plugged the other two wires into. Now I'm connecting the positive wire from the power supply directly to the positive wire of the LED matrix. You don't want to connect this wire to your microcontroller. Now I'm going to take another jumper wire and plug one end into the pin 6 of my Teensy board, my microcontroller. The other end is going to be plugged right into the data in of my LED matrix. Now I know that was hard to see, so here's a close-up. You've got the ground pin here and a pin 6. Over here you've got the row of pins going to ground. And then over here you can see my connections directly into the LED matrix wires. It's pretty simple. Now we connect our Teensy board or whatever microcontroller you happen to be using to the computer. Now I'm going to plug in the power supply. If you have a power supply like this, it's a good idea to plug it in before you connect it to everything, because when I first got it, it was set at 17 volts and that would destroy everything. So make sure it's set at or below, just below 5 volts for these matrix. So here's the code that we'll be using. This code's pretty short. I'm using 3 libraries you can see here. The GFX library, the Adafruit GFX, Adafruit Neo Matrix, Adafruit Neo Pixel, and down here I define pin as pin 6. And this next section here, these parameters configure the layout and the behavior of the matrix, and they define how the LEDs are arranged and how they're addressed. And we can just break down each part of this for you here. This section right here, it says that the LEDs move from bottom to top, and this right here says that the LEDs move from right and work their way left. And the columns part here, this indicates the LEDs are arranged in columns, and the zigzag portion indicates that addressing the LEDs follows a zigzag pattern. And you can see this if you flip the LED matrix over, they're in a zigzag pattern. Down here you see Neo GRB. This specifies the order in which the color channels are transmitted to LEDs, And then the Neo KHZ800, that's just the transmission speed in kilohertz. In this case, it's 800 kilohertz. This next section here, this defines an array of colors that contains one single color, and that color, since it's Halloween, is orange. This is RGB. This is red with a little bit of green, and it turns out to be a decent shade of orange. This first line in the setup, the matrix begin, it initializes the LED matrix for communication. Then you got the matrix.setTextWrap as false. That means that the text will not wrap, and it'll be clipped or cut off if it exceeds the space available. And then next we see the set brightness. That's obviously the brightness of the LEDs. And then the bottom one here, the matrix.setTextColor, we'll be using the colors array that we just defined a second ago. In this next part here, you've got an integer x and pass. This is the matrix width, and this integer pass equals 0 here. This is used to reset the color cycling after the text is scrolled off of the marquee. So we'll see that again down here in the loop. Down here in the loop, this first line matrix.fillScreen, this will clear the LED matrix. This second line here, the set cursor, will set the cursor for the text on the matrix, and then whatever you type in this section right here is what will be displayed on your marquee. And we want Happy Halloween. It can say anything you want it to say. This next line here, this checks to see if the text has gone off the edge of the display. You may need to play around with this number a little bit if you don't have an 8x64 marquee like I do, an LED matrix. You may have to play around with that number a little bit. Maybe a little larger, maybe a little smaller, but this is just right for an 8x64. And this next line right here, the matrix.width, this resets X to the width of the display, and it just basically wraps the text back to the right side. The next line is the set text color. That is the orange color that we defined earlier. And this pass variable here, this just cycles through the colors defined in the colors array, and it'll reset to 0 if it exceeds for us 1, because we have one color up here. Now down here, the matrix.show, that just refreshes your matrix, and then the delay is a delay of 1 second, or actually 0.1 seconds. It's 100 milliseconds. Now if you want your matrix to do some color changing, you could add a comma and then just copy and paste this. Let's say you just want a solid blue color, right? So 255. Come down here, change this pass to 2. And then after it goes through the orange color and then the blue color, and that's 2 passes, it'll reset to 0, so it'll go back to the orange color. Now you could add a third color, and you could just do a comma, matrix.color, and then add whatever color you want. You come down here and then reset this to 3, right? And after it completed the cycle of 3 colors, it would reset back to the first color and do the cycle again. So I uploaded the code to the Teensy board, to the microcontroller, and after playing around with it a little bit, I've got it to a good speed. The text goes all the way to the end, as you'll see here, and I put some paper over the LEDs just to diffuse it a little bit, make it look a little bit better. But with this code, it will continuously scroll, and once it reaches the end, it'll reset, it'll restart over again. Here's a look at some different colors without diffusing the LEDs. This is all I've got for today. I do appreciate you watching. If you enjoyed the video, be sure to like and subscribe, and share this with somebody else who might enjoy the video as well. See you again very soon.